Okay, so we'll start. In the previous class, we have started the neural network. So you got some gaps. So I'm again repeating this neural network and we'll be continuing our class. So neural network is a method in artificial intelligence that teaches and computers. So whenever you use a computer, that computer doesn't have any brain. So we have taken the inspiration of human brain, how the human brain works. We are creating the artificial intelligence in the form of neural networks, how the human brain has the neurons and all those things. Instead of neurons, we have created the neural network, and we are giving for the computers so that it can think on its own. This process is called deep learning, which is a part of artificial intelligence. So that here the nodes or neurons are connected such a way that it will resemble as a human brain. How the human brain works, we have done the same thing for this neural network. Next. So for every neural network, you have one input layer. So whenever I say neural network, we have one input layer. Then we have hidden layers. These hidden layers can be one or more hidden layers you can find here. And you have an output layer. So in the input layer, we are giving all the inputs. Okay. Suppose you are at a place where it is very hot. So input layer says that you have the outside temperature very hot. So that then there are some hidden layers to process how much you can sustain with that temperature, whether it's 40 degrees you can sustain or 45 degrees you can sustain. So these are the hidden layers, and you'll get the final output. How to react to the environment, we'll get the final output here in this case. Okay. Next, each node connects to the other as its own associated weights. So whenever if the n number of inputs are increasing, then we have to give the weight for that input. And we have some threshold value. If it reaches the threshold value, then only it will fires or it will activate. If the threshold value it doesn't reaches, then it doesn't activate. So there's a threshold value, how much it can sustain, then only it will start. Okay. Next, if the output of any individual node is above the specified threshold, that node is activated, sending data to the next layer. So this threshold is the most important thing. If the threshold is above the value, if the value of threshold is above, then only it is activated, the node is activated or the neuron is activated, then it will pass its data to the next layer. What it will do, it will pass the data to the next layer, and the next layer will decide what it has to do. Okay. Otherwise, no data is passed along the next layer of the networks. Then it will not start to the next layer. Okay. So next slide. So this is the example. So if you want to sell your house or any property, then these are the inputs, and output is nothing but the price. If you want to fix the price, genuine price, and for each and everything, you will assign some weight. Bedrooms, if the number of bedrooms are more, then how many weightage you will assign. If the age, nothing but how many years your house has been constructed, all those things. These are input layers, these are the output layers we will be checking here. Next example, if you want to find how the predict the temperature, whether it is a sunny, cloudy, or rainy, you'll give the inputs such as temperature, wind speed, visibility, humidity, and you will assign some weightages. So based on these weightages, you will find these things. These are the example of neural networks. Anything can be asked in the exam. This is more explanation. You have inputs. These inputs are x1, x2, x3, so on, xm. Then you have weight. Suppose for x1, you are giving 0.1 weightage. For x2, you are giving 0.4 weightage. For x3, you are giving 0.3 weightage. Okay. So this weightage, if I add all this weightage, it should be equal to 1. Okay. So example, this is 0.2 weightage. We are adding these weightages, and this x1 we are multiplying with the w1. This x2 we are multiplying with the w2, and so on. So here we are making the summation, and bias we are making summation bias. Bias is nothing but some, you can say that, like error or any extra thing are there that will add in the bias. If I add this one, if I'm making the round off value, then you will get some error. So you will have some bias values. So wi into xi, and it will be activation function. If the activation function, it is just like binary. If it is a 1, then it will activate. If it's 0, just like what we have discussed, the threshold value. If the threshold value comes as 1, then it will start. If the threshold value is 0, then it doesn't activate it. Okay. So it depends. If it is 1, then it will activate. If it's 0, then it doesn't activate. Then you will get the output. How to react to the environment or what to think, this is, you will get as this as the output. Next. How do neural network works? So this can be asked as a short answers. This can be asked as a short answers. How do neural network works? So in this case, uh, each node, you have each node. This each node has its own linear regression. Each node has linear regression model composed of input data. So here we have input data and weights and bias we have, or threshold we have, and an output. The formula looks like this. Already we have seen the formula. It is formula is same. So WAXI plus bias. Bias is nothing but the threshold value. We are checking the threshold value. So if we expand WAXI, W2X2, W3X3 plus bias, we need to add. Then we'll get the final output. Whether it is 0 or 1, you will get the final output. Then only it will be activated. How do neural network works? So once the input layer is determined, so you have to determine how many input layers are there. If you want to find anything, you want to determine how many input layers are there. Based on those input layers only, you will know. Okay. So you will get the final output. If the input layers are more, you will get the more output layers. Okay. Then you have to decide the weight. How much weight is assigned? You have to decide. Okay. So these weights are very important because larger the weight, suppose the larger the weight, example, you are giving 0.5 weightage, then it is the most important for that to get the output, more significant output compared to the other inputs. So if you are giving 0.5 weightage to anything, you are giving more than half or half weightage, then it is most important. You have to focus more on that input. Okay. All the inputs are multiplied with the respective weightage. Then it will pass through activation function. Then it will start with the activation function, which determines the output. Okay. If the output exceeds the threshold, then it will activate or fires, and it will go to the next. It will go to the next layer. And this process of passing data from one layer to the next layer defines the neural network. So in the neural network, the data is continuously passing from one layer to other layer, and it finally it has to give the output for us. Okay. Next, types of neural networks. So this is also important. They can ask anything in the exam. Types of neural networks. So first is feed-forward or multi-layer perceptron. So we have already seen single-layer perceptron. Similar to single-layer perceptron, you have multi-layers. So we have more than one layers or hidden layers we have. Then we'll get output layer. So generally, these are used to train them. And the foundation for computer vision. If you are using the computer vision, so that a computer is taking any of the images or all those things. If you want to analyze the computer with the image processing, then you will use this computer vision. So this type of feed forward neural network is used in computer vision, natural language processing, nothing but to convert one language to other language, and other neural network. We are using these things. Okay. Next type is CNN. These are similar to feed forward, but they're used only for image recognition or pattern recognition. So in the image, it will divide the image into n number of pixels. So if you take any image, it depends on pixels. So pixels we have if you want to have more clarity of the image, you have the pixels should be more for the image. So it will divide all the image into number of pixels, and it will find it can recognize the image, and it can also find the pattern recognition, whether the pattern is increasing, decreasing, or staying constant. We'll check. And also for computer vision also we use CNN. So here it uses So here it uses the principles of linear algebra and matrix multiplication to identify the pattern within the image. So if you are uploading any image here, so it will check the image, it will check the patterns, and by using the linear algebra method and matrix multiplication, it will find the final, it will find the image recognition it can possible. Next, recurrent neural networks, RNN, they are identified by feedback loops. So here in these two cases, you don't have any feedbacks. In these two cases, you don't have any feedback, but here you are providing a feedback so that you can check the error. So every time we are comparing with the input and output. So we'll check both the things, input and output, so that we can know that any error is available or not. Okay. Example, like if you are giving on a machining process, if you are giving that you need to cut 5 mm, but it is cutting only 4.5 mm, then until unless you see the feedback, you don't know whether it is working correctly or not. Okay. This learning algorithm primarily leverage using the time series data to make prediction. So example, if you want to predict how what will be the gold price in coming 1 year, then it will see the time series, it will see the past history of the gold, and it will see the time. Based on the time, it will predict the what the future outcomes. Example, like stock market predictions. If you are if the stock today is around 25 rupees, it will predict that whether the stock will go above or come below. It will predict the use for prediction, and because you have feedback, this feedback will measure the error and will give the correct output. Or for sales forecasting, so how many sales will be occurring for your company. Example, you are any bike manufacturing company or iPhone manufacturing company, so it'll predict how many iPhones will be sale for the, if you update for iPhone 16, then how many sales will occur, you can predict. Okay. Whether any new customers are there, or any existing customers will upgrade their mobile, so that you will know all these things by RNN method. Next, advantages. So in this advantages, first advantage is adaptability. So there is a so much of adaptability. You can see here, adaptability is nothing but it can adapt to any situation. It can adapt to any situation, whatever may be the situation, it can adapt to any situation. The link between input and output is complex and not well defined, because they can adapt to new situation and learn data from it. Example, you are create a robot and you are leaving it to environment, then it can learn on anything on its own. If you are asking a robot to plant a tree, water daily, then it can adapt new things day to day. Okay. From the previous data, it can adapt, or it can learn any new data. Whatever the new task you will give, whatever the situation it will learn those things and it will start working on it. Next, pattern recognition. So neural networks are mainly used for pattern recognition. So like if you want to check the any audio file or image identification. So there are few celebrities. So it can identify whether that audio tape or anything is correct or not. That you can find the pattern here. Okay. And image identification, you can also find similar images. If you upload an image, the similar kind of images you can identify by using neural network. And also natural language processing, you can convert one language to other language, or any data patterns it can identify. That is the main advantages. Next, parallel processing. So once you start the neural network, there are a number of inputs layers. Suppose there are 50 input layers, and these 50 input layers will work simultaneously or parallelly. These 15 layers will work simultaneously or parallelly. We speed up improve the efficiency of the computation. So you can calculate as soon as possible by using this one. Okay. By using this neural network, you will have the parallel processing. So it will help in this case. So everyone don't leave the Zoom meeting, because if you are joining the Zoom meeting, I need to give permission to join. So don't leave the Zoom meeting. Okay. Next one is non-linearity. So even though there are linear models and non-linear models, even though the models are non-linear, also it can run smoothly. So it can overcome the drawbacks of linear model. Okay. So whatever it can be same thing applicable for non-linearity also. Next, disadvantages. So first thing is disadvantage is compression integrity. If you have large neural network, training can be laborious in the it takes more time or more work. It has to do more work, and demanding process demand a lot of computing power. So whenever you are using neural network, you have to supply high power. The resources you are supplying should be very high for this neural network. And next, overfitting. Overfitting and underfitting, these are the two criteria in the neural network. In the overfitting, what happens is whenever any training material or memory is it is outside the area. So suppose we confine to area of approximately 50 GB. We confine to an area of 50 GB, but the data what we got is more than that data. If you got, we have to include the data also in this one. Then we are not creating any space. We are filling up the space. When we are filling up the space, it is called overfitting. Training material to the memory, it can identify the patterns in the data. Approach elevate this problem still exists. So even though if you have limited resources and if you are adding more and more data, because the data is generating again and again and you are adding those data, then it is called as overfitting. So that is the main disadvantage of the neural network. And underfitting is nothing but if you have space but you are having the very more free space, then it's called underfitting. So overfitting is a disadvantage and underfitting is also a disadvantage. Okay. Need for large data sets. So here we need to have sizable and labeled data sets. Labeled data set, sizable is nothing but it should be within the size. The size shouldn't be increasing continuously. So today it is around 100 GB. Then next day it has increased to 150 GB. Then it shouldn't be doing like that. If it is increasing continuously, then you need sizable. You need to have keep large database. Then you have to buy so much of data storage, and then you have to keep. And labeled data sets. Labeled data sets is nothing but you know the question and you know the answer. Label that he's a boy, he's a girl. When I upload any animal photo, it has to be even that it is a cat. It has to predict whether it is a cat, dog, or any other tiger or any other animal. It has to have the labeled data sets. It should be sizable and it should also be labeled data sets. Otherwise, their performance may suffer or incomplete. If the size is increasing, or else if you don't have any labeled data, or else you have to guess the label, then it takes so much of time for this one. Next. Next is application. So whatever I'm saying, anything can be asked in the exam. If they ask for neural network, you have to write what is meant by neural network. You have to draw the sketch of neural network. You have to give the working principle of neural network, then advantages, disadvantages, and application. Next, applications are nothing but facial recognition. First is facial recognition because it can identify the image pattern. It can recognize one of the main application is image pattern. It can find any image pattern. Suppose example, if you have uploaded any heroes photos in the Google and you are searching for those photos, then it can based on those facial expression, it can show the similar faces. Okay. Recognition system matches with the human face and compare it to the digital images. It can compare it with the digital images. So system authenticate human face and match up with the list of IDs that are present in the database. So if you are joining any IT company, there will be ID scan or face scan. Whenever you require very official, very top secret missions are there, then we are using the facial ID. So you have to initially you have to click the you have to whenever the process is there, just like your Aadhaar, instead of taking the fingerprint, they will take the facial recognition, or else in your mobile applications also they use neural networks. So some of the mobile applications have the face IDs. So before creating face ID, it will ask you to face to rotate in 360 degrees, rotate your face to left, rotate your face to right. Then it will store in the database. And whenever you open your mobile, it will authenticate whether you are a correct person to open that user information or not. It will. Okay. So that is the main application. Next, stock market prediction. So it will use multi-layer perceptron, MLP we call multi-layer perceptron. This uses feed-forward artificial intelligence so that we can check the past performance and annual returns and non-profit ratios for the MLP model. Past performance argument, whether the stock in the past 5 to 3 years, whether the stocks has been increased or not. Annual it is nothing but whether how many profit they have got based on their investment, how many returns they have got. Next, non-profit ratio. So every time not possible to get the profit. So what is the non-profit ratio? Non-profit ratio is nothing but based on what are your selling price is also equal to cost price. Then you will get non-profit ratio. So these are everything is considered to make the stock market predictions. Okay. Next, aerospace and defense. So in the aerospace and defense also, we'll be using the neural networks. So in the aerospace, fault diagnosis. Fault diagnosis is nothing but in the aerospace, we'll be fixing the rivets, nuts, bolts, all the things. So we'll check the fault diagnosis. If any nut or bolt is loosened and outside air is entering inside the inside this aerospace, then it is a very then it will be affecting the affecting the pilot or anyone who is driving the aerospace. So fault diagnosis is done by neural network. Okay, so and high performance autopiloting. Autopiloting is nothing but it is in the autopilot mode. Autopilot mode is nothing but even though the pilot is not sitting in the pilot seat, it can do the work on its own because we'll be training the computer by neural network. It has to work like a human brain. So even though the pilot is not available, the whether the uh, even the pilot is not available, that aerospace vehicle has to go up, go down, check the altitude, check the fuel, all those things. It will be done here. Okay, this is called autopiloting. Next, secure aircraft control system. So aircraft control system is nothing but it will check whether the fuel is there or not, or any enemies coming within our radar or not. It can check all those things by using the neural network. And dynamic simulations are also possible. Dynamic simulations are nothing but even though in the war situations, how you have to select a pattern from where you have to attack, and all those things simulations will be done in this neural network. And time delay neural networks can be employed for modeling non-linear dynamic system. So there are some time delay neural networks so that the time is delayed so that it can work efficiently. So those things can also be applied in the dynamic system. Next, coming to defense. In the defense, yeah, students are joining 319, joining late to the class. Okay. Next, defense. Neural networks are used in logistic armed attack analysis for object location, all the things. So neural networks used in logistic. Logistic is nothing but total how many weapons you required in the defense, how many hand grenades required, how many guns you required. It can check based on the war. And armed attack analysis. It can make your analysis that where the enemy is attacking and from where you have to attack. All those things, it will just like human brain also think from if the enemy is attacking from where you are attack all those things. So this is also make the same use of human brain. And for object location, suppose you want to trace any object, suppose uh, any pilot or any aircraft is coming in your radar or in your location, so you can check the location and you can track their location and you can fire the missiles on the object location. Okay. And air patrols, so there in the air patrols the pilots will be searching all the things whether any enemy has entered in our region or not, it will check. And maritime patrol, in the water also, in the underwater or by they're using submarine or any underwater, they'll be checking these things in this case. Okay. Next, controlling automated drones. So there are drones. These drones can work on their own. So just like there's no need of any person to control the drone to go left, go right, go above, or catch any images, those things. No need of anything. In the drones only, we are giving the neural network. We are giving the neural network or artificial intelligence. We are giving artificial brain to the drones. So what happened to the drones is the drone can roam freely wherever it has any suspicious activities going on. It can go to that place. It can click the image. It can send directly to the concerned person, to the defense officials. It can directly send. So these everything can be done by neural network. So these are the neural network is the most important for any of the things. Just like we are creating human brain to recognize anything. If you want to recognize your friends, you need facial recognition. That can be done by neural network. If you want to predict whether the price will going above, going below, how much price or how much stock you have to keep. So all these things you can make the prediction. In the aerospace, if there are any fault diagnosis or anything, or any autopiloting, how it has, even the pilot is not there, how it has to go. Securing the aircraft control. Aircraft control system is nothing but just on the runway, there should be only one aircraft. So if any aircraft is there, then that another aircraft has to roam in the air until unless there's any free available in the aircraft control. Because if you see Shamshabad airport, there are around 30 to 50 airplanes flights will be going on in daily. So they have to check the air control whether any aeroplane is landing or not landing. They have to check the aircraft control system is done by neural network. So we just give the number of airplanes we have and what are the timings. So even though if any airplane is delayed or other thing, it will check the aircraft control system automatically. Next, in defense, we'll use for patrols, air patrols, maritime patrols, and automated drones. We can use this neural network.